अभी स्लाइड विजिबल है? इज इट विजिबल?
Yes,
विजिबल है
sir.
क्या? डायग्राम इज विजिबल?
Yes, sir.
नहीं, दिस रेड कलर CMOS इन्वर्टर डायग्राम जो
Yes.
मैंने
Yes, sir.
विजिबल
Yes,
है?
sir. It is visible.
Yeah. So this is a example of a layout of a CMOS inverter. You can see correlate with the basic the schematic. This is called the schematic diagram, right? So we generally have VDD in ground. So you can make one metal lines and with have some width and length. Okay. So this can be considered as a width of the metal lines. This can be considered as a length of the metal lines, right? So that is why it is different than the stick diagram. It is have some, and there are where the contact has been placed, it has to be contact like black. There be square shape, or you can say right rectangle shape kind of contact should be there. So generally the dimensions are same. So we can all the edges are should be same for the making the contacts. Okay, so let's start with how to make a diagram. Okay, so basically, when you have like VDD, you can make a VDD line, okay, and the ground line at the bottom like this. You can prepare a ground line and VDD line separately, okay. And then we need to, as we know that we need to make a one transistor. So one transistor layout is what? Just a we have a strip, and then if you make a cross it, okay. So this is considered to be a layout of a one NMOS circuit for a, let's say for example, size. So size should be equal to it is equal to 2 lambda. What is lambda here? So lambda is basically come into the lambda design rule. Okay. So lambda design rule says that I'll discuss one by one what is the size of the let me go through the slide. Yeah. So this is called the wiring track. Okay. So wiring track and their spacing should be clearly defined, right? So a wiring track is a space required for a wire where it should be in terms of lambda. That is why it is called lambda design rule. So what do you mean by lambda here? So lambda is considered to be equal to it is equal to L by 2 basically, or you can say L is considered to be equal to 2 lambda, right? So that is why I am saying that polysilicon size will be equal to 2 lambda. Okay, and this is why it is represented in terms of lambda because when we scale that thing right in terms of lambda, so then it will be very easy as for us to calculate the overall area. Okay, and we can basically for different let's say for 180 nanometer what will be the lambda, and for 90 nanometer what will be the lambda will be different, okay, for different technology. Okay, so that is why instead of not giving a particular technology, that is written as a lambda based design rule. So in lambda based design rule, the lambda directly can be correlated with the particular technology. It may be independent of the technology. Okay, so for it will depends on the for 90 nanometer lambda will be different, 180 nanometer. So based on the library, which library you are using to design a layout, okay, that will decide the lambda. Okay, and then what are the lambda design rules basically? So this comes under lambda design rule. Let's say wiring track. Okay, what should be the size of the wiring track and what should be the spacing? Because when you are making a complete map kind of architecture, it is also important what should be the size as well as the space. So that is why it is mentioned here. So the transistor also consume one wiring track. Okay, so basically you can see this how it can be prepared. Okay, so the size of the wiring track should be equal to 4 lambda, and in between spacing between the two a wiring track should also be a 4 lambda. Okay, this is a one kind of a rule. Okay, you cannot, if you are violating this rule, it may be a problem that short circuit connections may be occur in future. Okay, So that is why a necessary dimensions has to be chosen, okay, for making the complete diagram or complete layout, so that and it is monitored through lambda. So if we are having length in terms of lambda, width in terms of lambda, then overall area will be equal to x times into lambda square. Okay, and lambda can be basically taken directly from the technology, 180 nanometer technology. Then you can multiply that number and you will get the overall area. So that will make the calculation very easier if you are using the lambda based design tool. Okay, so what is the design rule basically? So there are various things come into the picture. Like let's say for one for wiring track, that should be the difference. Okay, similarly, let's say what should be spacing between this thing considering. Okay, so this is let's say this is one PMOS and this is one NMOS here. So what should be the difference between this particular point to this particular point? Okay, so basically we need to put because it is a PMOS, okay, and we have a NMOS here. So in between, if you contact together, we'll make a output terminal also, and output terminal should be a wiring track, and wiring track dimension should be equal to 4 lambda. Okay, so that is why we need to keep the size in such a way that PMOS and NMOS should be apart a sufficient. It should be at sufficient distance. Okay, and what is the difference? So this is from the one PMOS layer to another NMOS layer. The difference should be equal to 12 lambda overall lambda, because the 4 lambda will consume the output terminal, and 4 lambda the spacing is required from the contact. Okay, initial contact it is required. Okay, so that is why the overall distance between the PMOS and NMOS should be equal to 12 lambda. Okay, is it clear? Okay, so let's say if we have I'll go to the first one, that is called inverter. Okay, so inverter layout. Okay, so you can see that if we are taking out here, the dimension is not taken properly. Okay, here just wiring tracks are given properly. Okay, because the size is not given here. Okay, so if you consider about the size, this wiring track should be equal to 4 lambda, this should be equal to 4 lambda. Okay, and then what about this small one? Okay, and this small contact should be size of equal to 2 lambda by 2 lambda. This is the design rule. Okay, so if there is a point of contact, okay, and then overlapping this layer, and this overlapping layer should be equal to how much? 4 lambda. Okay, so if it is a 2 lambda and 2 lambda, the in between the spacing should be there will be right side and left side, that is equal to 1 lambda and 1 lambda, right? That is also make it 4 lambda. Okay, so that is why the minimum contact has been taken as 2 lambda by 2 lambda. Okay, so these are considered under the lambda design rule. Also important is, you know, that this is the poly. Okay, and poly defines the gate of the transistor, right? So as you know that the technology is decided by the width of the transistor or length of the transistor. Hello?
Length.
Length, right? So that means we can we say that polysilicon length should be fixed for the particular lambda based technology?
Yes, sir.
Yes. So what should be the sizing of a poly layer? Okay, in terms of lambda. I just
More
said
than 16 lambda.
no. I am talking about only one poly. This poly.
2 lambda.
Yeah, it is should be equal to 2 lambda. I just said that the length should be equal to 2 lambda. So poly is nothing but what? It defines the gate of the transistor. So gate length is equal to, we can say, 2 lambda, right? So that is why this important things are required. Okay, so gate size will be equal to 2 lambda. So that is a, you can say, rule. Okay, you cannot deviate from this rule. Okay, and also the metal line should be equal to 5 lambda. This is also rule. And third rule, the contact should be size of 2 lambda by 2 lambda. This is also rule. Okay, and the difference between the two diffusions are equal to two diffusion. This is one diffusion and this is another diffusion. Okay, and between these two diffusion, what should be the gap?
12 lambda.
12 lambda, right? So this is also one rule. Okay, and the diffusion size also, generally this diffusion size, if we talk about the diffusion size, this diffusion size is also 4 lambda. So this is the diffusion and this is also diffusion. Okay, and it is separate from the metal. So metal size also be for same lambda hona chahiye, 4 lambda, and diffusion side also should be equal to 4 lambda. Is it clear? Okay. So now this is the let me complete how this is the layout of a CMOS inverter. Okay. So if we see that, if we correlate with this, just correlate with this diagram. Okay. I'll have first erase few things. Okay. Then I'll explain how it is belongs to one. So can you correlate this particular inverter layout, whether it is inverter layout or not, with the diagram, with the schematic? Okay. So just what is the, if it is a smaller design, that smaller design in CMOS inverter is considered to be a very smaller design, right? So for that, what is the method to draw? Just make one VDD contact first, ground contact first, and then you make a NMOS, PMOS, sorry, then NMOS, okay, and then poly, right, like this. And then after this is now because one section is crossing one, so this will be source, this is drain. Okay, so we have prepared the PMOS, you have prepared the NMOS, and then what is required? That the remaining are required the contacts. Okay, so you need to find out which is the source, which is the drain. So if you are considering this is the source, this is the source, and this is the drain, then just connect with the wire, so source to ground like this. Okay, and then connect this one to the VDD like this. Okay, so just once you prepare the NMOS and PMOS, VDD and ground, the remaining thing is all about connections. So also remember that when you are connecting to one terminal to another terminal, that should be width apart should be equal to 4 lambda, and the connection size also be equal to 4 lambda, because any connection has to be made is equal to size of 4 lambda, right? So what are the connections required? From this source to VGD, this source ground. Keep your mic off. Hello,
Right.
students. Please keep your mic off so that it will not disturb the class. Okay, so this is the example. Okay, so I give another example, right? How to calculate the overall area. So is it visible to all of you?
Yes, sir.
So here you can see there are different scales. This is another example. Okay, so can you predict that what is the layout here? What is the layout? For which circuit it is the layout?
Inverter.
Yes, correct. And what about this? Can you correlate? This is for CMOS inverter, right? Showing the different layer. That is just showing different layers. Okay, here metal contact, P diffusion, N diffusion, right? This is N diffusion, and this is P diffusion, contacts, polysilicon, just representing the different layers. So how many things you need to take care? 1, 2, 3, 4, 5. So 5 things you need to take care while designing any layout. Okay, N diffusion, P diffusion, and their color combination may be different. If you are going to the stick diagram, it is just a representation in the book. You can find out these details in the book. Which book you will follow? This is Neil West book. Okay, Neil West. This slide is from Neil West book. You'll find out the exactly same diagram available in the section of layout. Okay, right. So can we answer what is the layout of this particular what this layout represent? Which kind of circuit it represent?
Sir, is it NOR gate?
NOR. Okay, you're saying this is NOR gate. Why you are calling it NOR gate? So
Sir,
this is
because
the point, right? Yes.
Because the NMOS is connected in series and only one end is connected to the ground and another end is connected to output.
Yeah. So this is connected in series. So you can see the ground one, right? So which terminal is connected to ground? A source terminal, right? This is the source point. So we can start with ground, making the things. This is one only transistor that is connected to the ground, and what is the transistor? A transistor, correct? So A transistor is connected to ground, but if any other terminal should be connected to ground, that means it should be in parallel. Yes, and there should be contact point also. Similarly, you can see this point is connected to ground, A point is connected to point, and B and C. These are the common points of B and C, and B and C is also connected to VDD. So that means we can say A is parallel with B is parallel with C. Yes. Yes or no?
Yes, sir.
Because A is connected to one point, B is also connected to another point. Okay, this is means you can say we are having like this kind of structure. Like this. This is A point and this is B and C, common point. So this can be a transistor B and transistor C, right? Now later you need to see whether the second terminal is also connected to the common points are on, like A and B. This is the A and B common point. It is connected to one point, so I can join one A and B. And similarly, there's another C point. C point is also connected to the common point, so I will connect like this. Yes or no? This is why. Simple. This is why. So the above three transistors should be in parallel, and you know that if anything is there, so PMOS is always complementary to the NMOS. So this will be like this. And which of the transistors should be connected to ground? A, because this A is connected to the ground. Okay, and which is connected to the output? C is connected to the output. You can put C here. So obviously the second point will be equal to B. So which gate it is? 3 input NAND gate or NOR gate?
NAND gate.
It's a NAND gate.
Yeah, so it is a 3 input NAND gate. Clear? It is not a NOR gate. So just you can correlate with the connections and then you can easily derive which kind of layout it is. So I am just telling it circuit to layout, and similarly you can vice versa is possible. If the questions comes like find out which kind of layout is for, draw the schematic for a particular layout, so then it will be also one type of questions. Okay. Okay. So this is about the let's say calculate the overall area. Okay. So You can see if you want to make a detailed study, like this is the also NAND gate layout, okay, where has been shown the different layer. You can see this A is connected to the ground, this is A is connected to VDD, and the common point, the same thing is there, okay. Only difference is that to use this is also this and this to make a contact, okay, properly. So this is the layout. Earlier were just a not in detail, right? Earlier you can see this is the making some overlap kind of thing, right? Okay, so this should be instead of instead of that, the another way of designing this, sorry, let me come to the, yeah, another way of designing is this one, okay. So in this way, because in this way we can find out the overall area, right? So what it is required basically, if we are making is a, let's say for example, this is a complete chip, okay, example IC, it is a complete IC. So what we have to do, the first upper one is spaced 4 lambda, okay. That 4 lambda space we need to keep it safe, okay, not utilized. So we'll start with our the first layer after this from this particular point, okay. So if we compute all this, the spacing between all this particular point to this particular point, you can see from this particular point to this particular point, it is showing is how much? Total 40 lambda. Similarly, if you take a horizontal one, so it is equal to 32 lambda. So can I say the area of the particular chip is equal to how much? 32 by 40 lambda, that is 32 by 40 lambda square, okay. And you know that what is the lambda meaning. So if it is given as a, let's say 180 nanometer technology, so you can calculate the overall area, yes or no? Okay, so any design basically, if you preparing, the cross check is that always you will get the things in multiple of 8 lambda, 8x. This is also 8x, okay. So height and width always you design, okay. And if you are by doing some mistake, then just calculate the values and you can see that it should be a multiple of 8 lambda, 8x, okay. So the 32 is nothing but 8 multiplied by 4, and this is 8, 40 is nothing but 8 multiplied by 5, right? So always you will get such type of figures, okay. There should not be any case where it will be 26 lambda or any 33 lambda, not like that, okay. Always it should be a multiple of 8 lambda when we compute the total length and width of the chip. I'm talking about the area. So area consists of the complete, the horizontal width as well as vertical width, okay. So from here we can say for a particular integrated circuit, this should be equal to 32 multiplied by 40 lambda square, okay. And from that we can easily calculate the overall area of the layout. Okay, so let's say do some exercise, okay. So estimate the area by counting wiring track and multiply by 8 to express in lambda. It's okay, it is just a exercise, okay, how to calculate the overall estimation. You can see that each track has been shown by arrow, and each, if you compute the total one, it is always come in multiplication of, it is the same structure, right? It is the same 3 input NAND gate is there. So these arrows are in detail, okay. You can see compute how, why it is coming to 32, okay. So this is, for example, this is what should be the size of this, what should be the size of this particular poly?
2 lambda.
2 lambda, right? And what should be the size of this cross contact?
It is also 2 lambda by 2 lambda.
Yes. And what is the spacing between these two?
One lambda on each side.
So you can see this arrow represent how much? This what? Horizontal arrow represent 8 lambda. This is also 8. This is also 8. This is also 8. So that will max the total equal to how much? 32 lambda. Right. So you can say this is right 8 lambda. And what is the size of this strip? You know that the size of this strip should be equal to
2 lambda.
not 2, 4 lambda. Right. The size of this strip should be equal to 4 lambda always. Sorry, this is the upper.
Sir, it should be 2 lambda.
This is upper wiring track should be equal to
Yes, sir. So this should be 2 lambda.
This should be 2 lambda.
Yes, sir. Then only symmetry will there will be symmetry in this.
Okay, if you consider 2, then this is also 2 and this is also 2 you are counting, right?
Yes, sir. Yes, sir.
No, it may be spacing should be 1 also, and this is 1. Let me check with this diagram. Yes, this number of tracks is there. Just check it here. The 5 tracks. This is 40 lambda. This is the 6 tracks we have. The 5 tracks says that it is between the this particular point. This particular point. This is always 2 lambda. Okay, there is no. This is if it is cross section, we are cutting it to. So this line will be equal to 2. Okay, 2, 2, and this is after this space will be also equal to 2 and 2, right? So that will make it equal to 8 lambda. Clear? So as I know that contact size, this contact size should be equal to how much? 2 lambda. 2 lambda by 2 lambda. So that is fixed. So we can say the overall, this is the sketch, one of the example in terms of questions. Okay, in the examination question, that sketch a stick diagram, or you can say layout for O3 AI OR3 and invert. O3 AI means this is OR3 means OR3 and an invert. Okay, O3 AI. What is this O3 AI stands for? So what is the meaning of this? This is what? This is the circuit Boolean expression. OR3 means this is 3 inputs are odd, right? A plus B plus C, and then and then invert. This is dot is and that dot is invert. So this is one way of representing. So OR3 O3 AI. Okay. So stick diagram for O3 AI and estimate the area. Or you can say stick diagram. Instead of stick diagram, you can say this is layout. Okay. Draw the layout, sketch up the layout, and estimate the area. So this will be just a given question. Okay. And accordingly, what you have to do, you need to make first stick diagram. ठीक है, तो आपको कौन सा रूल फॉलो करना पड़ेगा? कौन सा? Euler's path, right? So by using the Euler's path, you can make a stick diagram and then give dimension to the stick diagram. That will make a layout. Okay, and after doing the layout, what is required? You need to estimate number of tracks. So always you will get the result in terms of horizontal as well as vertical in terms of 8 lambda, right? 8x. Always you'll get the in terms of 8x. If you had drawn incorrect, then you can basically correct by yourself. So you can see this different tracks are there: 1, 2, 3, 4, 5. that is here the size is big. Okay, so that is why they are writing is the 6 tracks. So please go to details in the book. You'll find out detail in the book. Okay, how to draw. Okay, so for any complicated because these are the simple one. Okay, these diagrams are the simple one. So you may not require a Euler path because you can say Euler path A B C D is directly there. Okay, so according from the circuit diagram itself you can make the connections. Okay, but what about if any circuit is complicated? So if in that case we apply the Euler path technique, so that we'll have the minimum number of interconnections, so that our layout will be no cross connections. Okay, the track should be properly defined and it should contain minimum tracks. If it is a minimum tracks, though you can say it is a minimum area. Is it okay? So any
Sir?
questions? Yes, yes.
So why have we considered 4 lambda extra spacing above stick diagram but not below stick diagram?
कहाँ पर बोल रहे हो? ये इधर, ये ऊपर?
हाँ सर, ऊपर कंसिडर किया है, एक्स्ट्रा नीचे नहीं किया ना।
नहीं है ना, नीचे भी तो है। कहाँ देखो
सर, नीचे मतलब ग्राउंड के नीचे नहीं है ना, यहाँ पे वीडीडी के ऊपर भी कंसिडर किया है।
दिस इज जस्ट ए कन्वेंशन स्टार्ट करते हैं फॉर देयर शुड सम पिन विल बी टेकन आउट और फॉर दैट वी बेसिकली कीप द स्पेस।
नहीं सर, while calculating the total height it is coming out to be 36 lambda, तो 4 lambda ऊपर इसने शायद एक्स्ट्रा स्पेस कंसीडर किया है, तो मैं पूछ रहा हूँ कि नीचे क्यों नहीं कंसीडर किया, सिर्फ ऊपर ही क्यों लिया एक्स्ट्रा।
अच्छा, ये आप कैलकुलेट कर रहे हैं, इधर वर्टिकली कैलकुलेट कर रहे हैं 48 लैम्डा, राइट?
यस सर, 36
36 हो रहा है
सर, वो उस वाले में जो आपने 3 इनपुट NAND गेट बताया था,
ये वाला ना, ये दिस वन।
यस सर,
दिस इज 40 लैम्डा। हाँ, सो ऊपर एक ही ऊपर स्पेस छोड़ने का यही रीजन है कि दिस इज वन कन्वेंशन बेसिकली, मतलब वीडीडी सप्लाईज के लिए थोड़ा सा स्पेस वहां पर रखते हैं, दैट्स इट। नो, आई डोंट नो द व्हाट इज द एग्जैक्ट रीजन बिहाइंड इट, ठीक है, बट दिस इज द कन्वेंशन दे फॉलो इन द बुक in any kind of design style. Your question is correct, but I don't know the reason correctly. I'll let you know. Is it okay?
ओके सर, ओके।
Sir, how do we know that there are only like if in here the arrows are made, but if we don't make the arrows, how will we calculate like this area is one track, this area is the other track?
So that's why I told now initially in the discussion, you should know what should be the size of each layer. So we have total 5 layers. I'll come to this. Okay, so what should be the size of one layer metal? What should be size of P diffusion? What should be size of N diffusion? As I told, P diffusion should be 4 lambda, N diffusion should be 4 lambda, polysilicon one layer should be 2 lambda, metal layer size should be equal to 4 lambda, contact should be equal to 2 lambda by 2 lambda. So these are the 5 design rules we have. Based on that, everything is met. Okay, and then the another rule is that this is the size of that particular given, and also another rule is that what should be the spacing from one region to another region, right? Like if there is a contact like P diffusion to metal, what should be the spacing as per the guideline, that you need to take care, spacing also. Then you are then able to come to the overall calculations. Is it clear?
Sir, like could you please show the diagram in which track or need I need to ask something?
ये डायग्राम तो है
सर, वो ट्रैक वाला
ये वाला
नहीं, वो जहाँ ट्रैक बने हुए हैं, मतलब 40 लैम्डा एंड 32 लैम्डा।
सो नहीं, एक यहाँ पर एक देखो, दिस इज द कॉन्टैक्ट, राइट, एंड दिस इज व्हाट, दिस इज द पॉली, ठीक है। इस पॉली के कांटेक्ट में अब देखो, ये जो छोटा कांटेक्ट है, दिस इज जो बड़ा कांटेक्ट है वो विथ लाइनिंग जो है 4 लैम्डा है, तो छोटा कांटेक्ट कितना होगा, 2 लैम्डा होगा, राइट, 2 लैम्डा बाय 2 लैम्डा, यस। और ये जो पॉली है, पॉली का साइज कितना बताया यहाँ पर 2 लैम्डा हुआ। तो कैन वी से द स्पेसिंग बिटवीन द कॉन्टैक्ट एंड पॉली कितना होना चाहिए?
1 lambda.
हाँ, ब्लू लाइन से 1 लैम्डा होना चाहिए और ब्लैक लाइन से 2 लैम्डा होना चाहिए, राइट? So this is also one kind of rule, okay, that you need to take care while drawing. Then if you know the spacing clearly, then you will able to make the diagram and you can correlate with this number. ये पूछ रहे हो, ये वाला बताओ क्या पूछ रहे हो?
हाँ सर, जो नीचे वाला मेटल कांटेक्ट स्ट्रिप है, जो डिफ्यूजन लेयर है एनमॉस वाली,
ये वाला, ये
हाँ,
वाला, हाँ हाँ
ये
हाँ।
वाला ट्रैक की लेंथ 8 लैम्डा कैसे है? वो वाला जो ट्रैक है जो इसके बगल में शो है।
अच्छा, ये ऊपर वाला पूछ रहा है, ये वर्टिकल या हॉरिजॉन्टल?
सर वर्टिकल।
इस पॉइंट से इस
हाँ,
पॉइंट,
इस पॉइंट।
ये बोल रहे हो आप? हाँ,
यस सर।
अच्छा, दिस पॉइंट टू दिस पॉइंट। तो ये देखो ना, पहले बताया था ना कि टोटल जो डिफरेंस है कितना कितना लैम्डा का हुआ?
सर इसमें
सर
तो
12
मेटल
लैम्डा।
2 लैम्डा।
नहीं, 12 लैम्डा तो स्पेस हुआ ना। ये यहाँ यहाँ तो यहाँ 8 लैम्डा इसने दिखा दिया, और यहाँ से यहाँ 4 लैम्डा हुआ, और इसकी साइज भी आपकी 4 लैम्डा होगी ना, तो तभी तो होगा।
सर पर मेटल स्ट्रिप तो हम 2 लैम्डा ले। अच्छा कनेक्ट, हाँ ठीक है सर।
ठीक है,
ओके सर।
तो 4 है होगा। सो बेसिकली मैंने बताया था डिफ्यूजन का जो साइज होगा वो 4 लैम्डा का होगा। वो जो दो टाइप के कांटेक्ट हैं, एक स्मॉल कांटेक्ट एंड बिग कांटेक्ट। बिग कांटेक्ट 4x4 का हो जाता है, और स्मॉल कांटेक्ट जो अंदर शो करने के लिए होता है वो 2 है। वो एक्चुअली दो टाइप कांटेक्ट इसलिए है कि एक छोटा जो कांटेक्ट होता है वो फॉर डिफाइनिंग द सोर्स एंड ड्रेन, ठीक है। बड़ा वाला जो कांटेक्ट है वो क्या होता है कि आप जैसे आपने यहाँ से एक एनमॉस बनाया, ये वाला कांटेक्ट 2x2 का होगा, है ना, राइट। और उसके नीचे फिर एक और एनमॉस हुआ, ये वाला कांटेक्ट भी 2x2 का है, राइट। अब इन दोनों को जब हम मर्ज करेंगे तो इस तरीके से मर्ज करेंगे, तो जब ये मेटल स्ट्रिप से कांटेक्ट होगा तो इसकी साइज 4 लैम्डा के विड्थ के साथ होगी। आर गेटिंग द पॉइंट?
यस सर।
हाँ, तो इसलिए
सर
वो,
एक
हाँ
सर एक हॉरिजॉन्टल का एक्सप्लेन कर सकते हो कि हॉरिजॉन्टल में 4 लैम्डा का?
ये वर्टिकल का हुआ, हॉरिजॉन्टल का बोल रहे हो आप, है ना।
यस सर।
तो हॉरिजॉन्टल में भी जैसे अब एक ट्रैक्स बनाया था वहां गए थे, Sorry, ये है ट्रैक, ठीक है। यहाँ पर देखो एक जो वायर्स है वो 8 लैम्डा के इक्विवेलेंट बनाया है ना। तो विल ट्राई टू अंडरस्टैंड। So this particular point to this particular point, right, ये वाला पॉइंट है, और वहां से ये वाला पॉइंट, एक मिनट, this is not there, okay. So basically this point to this point is that, तो यहाँ एक ये हुआ, और एक ये हुआ, और एक ये हुआ, और एक ये हुआ, 4 चीजें हुई, राइट, है ना। तो ये इसका साइज आपका तो फिक्स है ना, 2 लैम्डा बताया था, तो था दिस इज 2 लैम्डा। फिर ये दो स्पेसिंग 2 लैम्डा, इधर भी 2 लैम्डा एंड 2 लैम्डा, तो टोटल विल बिकम 8 लैम्डा ना। और इफ यू कंसीडर द स्पेसिंग, एक मिनट, हाँ वापस, इसलिए मैं ये बता रहा था, ये जो पॉइंट्स है, लेट मी कम टू दिस पॉइंट। हाँ, इस तरीके से होता है, जो भी कनेक्शंस है वो इस तरीके का है, राइट। सो जो भी रिप्रेजेंटेशन 8 लैम्डा यहाँ पर दिखाया है, तो 8 लैम्डा क्या होगा, एक पर्टिकुलर इस पॉइंट से लास्ट पॉइंट तक जो है वो 8 लैम्डा को, तो 2 लैम्डा जो है पॉली की साइज हो गई, 1 लैम्डा गैप हो गया, और 4 लैम्डा जो इस कॉन्टेक्ट का साइज हो गया। तो जहां भी एक इस तरीके का कनेक्शन दिख रहा है, इट मे बी एट हॉरिजॉन्टल और वर्टिकल, द साइज विल रिमेन सेम, ठीक है। और जैसे
Okay, sir.
इसलिए यहाँ पर भी दिखाया जो गैप है वो 4 लैम्डा होना चाहिए, वर्टिकली गैप हो गया, हॉरिजॉन्टल में भी उस तरीके का ही बनेगा ना, चाहे ऐसे कट करो या ऐसे कट करो, इधर तरीके से जैसे इधर बात करेंगे तो ये इस पॉइंट से इस पॉइंट तक कितना होगा, 4 लैम्डा होगा, फिर यहाँ से यहाँ तक मैं ले लूंगा तो इट विल बिकम इक्वल टू हाउ मच,
8 lambda.
8 लैम्डा, ठीक है। Okay, so I'll suggest and go through the book. If you have any other doubt, then we can discuss in the next class. Okay,
Sir, attendance.
Attendance. Yes, you can mark your attendance here. Yes, I have started the attendance. Please mark your attendance here.